Hi again. My name is Shaoor Munir. I am a third year PhD student at University of California, Davis. Today I'll be presenting our work on creating Purell, uh, which is a tool for safe and effective sanitization of tracking link decorations. This work was completed in collaboration with researchers from Imperial College London and Washington University in St. Louis. Before talking about Purell, let me first talk a little bit about what a link decoration is and some measurements which helped us in creating this tool. Over the past few years, we have seen several efforts by major browsers to try and restrict conventional ways of tracking users. The biggest of which is the phasing out of third-party cookies. Firefox and Safari already block third-party cookies, and it is expected that Google will soon also follow suit. In addition to blocking third-party cookies, there have been some efforts by Google and others to restrict fingerprinting as well, using privacy budget and other proposals. Protections against CNAME cloaking and other forms of tracking have also been adopted by browsers in the past. And it is expected that as new tracking techniques keep popping up, these restrictions will become more broad and extensive. In spite of all these efforts, trackers are always looking for new ways to identify users. Since third-party cookies have been blocked, we have seen significant adoption of first-party cookies by trackers. And to circumvent restrictions against fingerprinting, new techniques which involve hardware fingerprinting and other side channels have also been discovered. Since it always has been a cat and mouse game between trackers and anti-trackers, these new forms of tracking will always keep coming up. So the question that comes to mind is there a more catch-all solution to prevent tracking? So the one thing that is common between all these different tracking techniques is that it requires exfiltrating information about the user to tracker's own servers. It does not matter if that information is stored in a cookie, it comes from a complex combination of different fingerprints, it is obtained from the user itself in the form of email addresses and phone numbers, or even if it's some other form of new tracking which might be discovered later. Unless the information leaves the user's device, tracking cannot happen. And our measurements, which we will discuss shortly, has shown that link decoration is the prevalent way for trackers to achieve this information exfiltration. And thus, it also provides us with an opportunity to prevent tracking at the last mile. But what actually is a link decoration? Consider this example URL, which shows a search query for art institutes in New York. The URL of this query is divided into 5 different parts. The first part is called a scheme, which contains information about the protocol being used by the server. The second part is a fully qualified domain name, which identifies the web server. The third part after the slash is a resource path, which traditionally points toward the directory of the web server. However, it can be repurposed for other endpoints as well. Resource path is followed by a question mark, which marks the beginning of query parameters. Each query parameter is separated by an ampersand and is in the form of a key value pair. Lastly, a hash at the end of the URL typically signifies the start of fragments. We call the resource path, fragments, and the query parameters as link decorations. These are additions to the original address of the web server and can be used for both functional and tracking purposes. For example, in this URL, the query parameter type is used for functional purpose as it specifies the type of art institute the user is searching for, while GCLID is used for tracking purposes as it is used by Google for analytics and click identification in Google ad campaigns. Removing some of these non-functional tracking link decorations from the URLs can effectively prevent tracking. However, if there's a mixing of functional and tracking link decorations in the same URL as we saw in the previous example, this becomes a challenging task. To see how prevalent and difficult to solve this tracking by link decorations is, we conduct a measurement study to answer the question, are trackers using link decoration? And if the answer is yes, how are they using link decoration? For this purpose, we ran a crawl on a sample of top 1 million different websites, out of which 1,000 are top 1,000 most visited websites, 9,000 were sampled from sites ranked between 1,000 and 100,000, while the rest 10,000 were sampled from sites ranked 100,000 to 1 million. So in total, we ran this call on around 20,000 websites. And our measurements show that 45.5% of all link decorations that we observed were being sent to advertisers and trackers. We rely on existing filter lists such as EasyList and Easy Privacy to identify URLs which belong to these advertisers and trackers. We also discovered significant mixing of tracking and non-tracking link decorations in the same URL. Not only that, we also found that the same link decoration was being used as functional link decoration in one context and tracking in another context. The query parameter v with key v used by Google is an example of such link decoration. This means that isolating and removing tracking link decorations is a non-trivial task, and we need a tool or countermeasure which can automatically detect and restrict tracking link decorations based on their individual behaviors on each different website. Our measurement study also helped us better understand these behaviors. We observed that link decoration contains values which originate from sources such as first-party cookies, fingerprints, and other identifiable information such as email addresses and phone numbers. Tracking link decorations thus normally involve interaction with scripts which collect this information through first-party cookie storage and other APIs. We also observed that sending this information also resulted in the tracker returning a user identifier, which is then stored in a first-party storage. We boil down and identify following behaviors of tracking link decorations. One, they are used to exfiltrate values stored in browser storage. Two, they are sent to endpoints which send back user identifiers to be stored in browser storage. Third, they also coexist with several other link decorations. And finally, they are usually made up of strings which can contain more information about the user, which means that they are higher entropy strings. We model these behaviors in a graph which represents interaction between different elements of a web page. Here we demonstrate modeling of these features through our graph representation. Our graph representation is based on dynamic analysis of the web page and the interaction of different elements within the web page. For example, here an example JavaScript here is reading browser storage named info and sending a request to a search endpoint. This request contains two different link decorations, with one of them containing the value of the info storage. Our graph monitors this behavior and adds an edge from the storage node to the link decoration node. In addition to this, JavaScript can also send a request to a tracking endpoint. After receiving a response from the tracking endpoint, a user identifier is stored in the browser storage. This infiltration of user identifier is also monitored and represented as an additional edge in our graph, along with any other exfiltration that happens for that user identifier to other tracking endpoints. Other behaviors such as entropy information, etc., they are encoded as attributes in the graph. This graph representation helps us create the feature set for our classification pipeline. For ground truth, we use a combination of filter list and Wikipedia. The tracking labels for the link decorations come from filter lists maintained by AdGuard, uBlock Origin, AdBlock Plus, Brave, Firefox, and Safari. In total, we were able to obtain labels for around 1100 tracking link decorations from these filter lists. We also label link decorations used to exfiltrate tracking cookies identified in Wikipedia database. Wikipedia is an online database containing information about purpose of cookies declared by sites themselves because of regulations such as GDPR. We also label link decorations which are part of requests sent to endpoints that are not present in any other filter list and as non-tracking. And our model ultimately classifies the given link decoration as either tracking or non-tracking. To give an overview of the whole model, we first crawled 20,000 websites using an instrumented Firefox browser. We collect interaction between different elements on the web page and extract relevant information. We then create a graph representation of these interactions and compute the relevant features. This data is then labeled by combining information from Wikipedia and filter lists. Finally, we feed this data to an ML model, which is trained to classify if a given link decoration is tracking or non-tracking. Now coming towards some of our results and conclusions that we drew from them. We compared the results of our classifier with 4 other approaches to restrict tracking link decorations. The first one is Crumb Cruncher, which is a research project led by folks at Brave and UC San Diego. They use multiple parallel crawls to identify link decorations which retain their value for the same user. This allows them to isolate tracking link decorations from non-tracking link decorations. Second one is Wikipedia, which labels cookies as tracking and non-tracking. We use those labels to identify tracking link decorations which directly exfiltrate those cookie values. We also compare against request-based filter lists such as EasyList and EasyPrivacy. For request URLs which are labeled as tracking by this filter list, we consider all link decorations present in those URLs as tracking, and vice versa for the non-tracking link decorations. Finally, we also compare against link decoration specific filter lists such as those used by AdGuard, uBlock Origin, Brave, Safari, and Firefox. Looking at pure accuracy numbers, Purell outperforms other tools by at least 6%. Important point to note here is that in addition to having higher accuracy, Purell is also highly precise. This is important as link decoration based filter lists, although they are extremely precise, they miss 90% of tracking link decorations. While request based filter lists, although they do offer much better accuracy and recall, have a lower precision. Having both higher precision and accuracy means that Purell is not only able to effectively restrict tracking by link decorations, but is also less likely to cause breakage as a result of mistakenly blocking functional link decorations. To test this claim, we now conduct a breakage analysis. We conduct this breakage analysis on 1,000 different websites. To do this analysis on scale, we make use of a perceptual hash-based algorithm that compares the difference in sites with and without blocking tracking link decorations identified by each tool. This approach gives us a list of sites where there is a significant difference in a website when a tool is used, and then we proceed to manually verify the breakage on that site to ascertain whether the impact of restricting tracking link decorations has some negative effect on the website. We resort to manual verification here as automated breakage analysis is still an evolving field and no method is accurate enough to allow a completely automated analysis pipeline. We observe that Purell results in breakage on only 7 sites. While its closest competitor in accuracy, the request-based filter list, they caused breakage on 62 sites that we tested. This shows that Purell is not only accurate in identifying tracking link decorations, it does so without causing degradation in user experience. Now that we have a reliable ML model, we can conduct a large-scale study of the trackers, and we do so by running Purell on an unseen dataset of 20,000 websites. Next, we will see some interesting results that we observed by deploying Purell in the wild. Looking at the percentage of sites which are using tracking link decorations, our analysis shows that only 1/4 of the sites are not using any tracking link decorations, while the rest of the 73% of the sites send at least one tracking link decoration. On these 73% sites, we observe that 93.3% of tracking link decorations are query parameters, while 6.6% tracking link decorations are resource paths. And fragments make up a very minor percentage of tracking link decorations. We also observed that on 69.4% of sites on which Purell was deployed, at least one storage value was sent through these tracking link decorations, highlighting the extensive use of link decorations in sending out identifying information about the user. And this is not limited to only browser storage. Purell also identified 62 link decorations which were used to send out user email addresses to third-party trackers, while 200 tracking link decorations were found to be sent by scripts which are also involved in fingerprinting. Tracking through these link decorations is not limited to a single tracker. We also found that these link decorations are not only used by a tracker to exfiltrate information to itself, but are also extensively used to share user information with other trackers. Here we see a chord diagram showing the pattern of link decoration sharing among popular trackers. We see a lot of collaboration between Raptive, OpenX, Rubicon project, and Yahoo. However, Google is the most egregious one here, with user information being shared to Google by 9 of the top 20 trackers that we analyzed. Looking more closely at Google's example, we found that Google extensively uses link decoration for receiving data about users. Google_HM is a query parameter used as a container for information about a website visitor. This information is used by Google for its first-party cookie matching service. We observe companies such as AdForm, Freewheel, Rubicon Project, Yahoo, and others sending Google this link decoration on multiple different sites. Currently, this tracking parameter is not blocked in any of the link decoration-based filter lists. While these results might be interesting to discuss on their own, I think the most relevant question to this audience is how does Purell help in the ad filtering community? Some of the privacy-focused browsers like Firefox, Safari, and Brave, and some of the extensions such as AdGuard, uBlock Origin, and AdBlock Plus are already using a limited list of tracking query parameters. However, we believe that those lists are not extensive enough to protect user privacy. In total, we found only 1,100 link decorations to be part of these filter lists. On the other hand, our deployment shows the presence of more than 196,000 tracking link decorations on a sample of top 1 billion sites. A number of widely used query parameters that we have identified in our analysis, such as Google_HM, GPIC, GAC, etc., they are not included in those lists. These missing query parameters, which constitute more than 93% of all the tracking link decorations which are identified by Purell, they can be easily added to those existing lists to enhance privacy protection that these browsers and extensions provide. We have already released the list of link decorations identified by Purell on GitHub, and the source code is also freely available for anyone to use. And we hope that it will be able to enhance effectiveness of these privacy-enhancing browsers and extensions in the future. Thank you for listening to the presentation, and I'm looking forward to any questions that you might have.
Thank you, Shaoor. So, do we have some questions? Where's the magic cube? Where did it go? There is one. Do we have a mic too?
I have a mic, but not the box.
Not the box, but can you switch him to live? Okay, then go ahead.
Okay, sure. I noticed the 4 parameters in the very last slide. Like, I run, I think, the second most popular list to specifically remove such parameter decorations. But I kind of need example URLs for them. You are welcome to suggest them to me on my GitHub repo, Dandelion Sprout Adfield, and I will look through them within 2 days. That was it.
Okay, sounds good.
Okay, sure. That was it.
Wonderful.
Okay, and this was more.
I'll collaborate with you offline. Thank you so much.
Anybody else? Hugh's here, but where is the magic cube? Where'd it go?
I have it.
Perfect.
Hey, Shaoor, this is Hugh. Great presentation.
Hey.
I was wondering, when you block tracking based on these link decorations, what's the percentage of tracking that you actually block for a website? Does it cover the majority of tracking, or is it only like a special set? Does that make sense what I'm saying?
Right. So the idea behind this whole exercise is to to stop the exfiltration of information going out. So ideally, if we are able to identify all tracking link decorations and we remove them from those request URLs that are going out, then effectively those URLs become sanitized. And this should effectively prevent all sort of tracking that can happen for a user. Because for the tracking to happen, there needs to be some information about the user itself that needs to go out. And in an ideal case where I think based on the ground truth that we have very good accuracy there. In an ideal case, sanitizing those URLs should prevent or should be comparable to using a filter list to actually block the request URLs themselves. So essentially, we are cutting down on the information about the user being sent out, and we are also preventing any tracking happening that way.
But what about tracking that's based within like the request body? That doesn't stop it, right?
Right. So some of the future work that we wanted to do with Purell was to actually expand this analysis to the request body itself, some of the custom headers that some of the trackers are using, and the payload information as well. So there might be some information which is going out through those areas as well. But I think that Purell itself, it's based on the way that the graph is constructed, we can easily extend it to other sources of information which are being used, other sources which are being used to send out information about the user. So yeah, currently it's only looking at link decoration itself, but yeah, this can be extended as well in the future to other information sources as well.
Hi, great talk, thank you. I was curious if you have measured how many of those query parameters you found would be sent or not when using an ad blocker in general versus just running without ad blocking.
Right. So we did compare against the popular filter list, Easy List and Easy Privacy, and we observed that they were around, I think the actual improvement in recall is around 8%. So we did, there is some difference in some of the tracking decorations which have been sent out. The exact number itself, I think we have reported in the paper itself, but yeah, there are around 8 to 10% of link decorations which were being sent out even when we were using Easy List and Easy Privacy to block requests.
Keep it short.
So at the moment we're using remote param to, I guess, prune what we need to prune. Is it possible to either modify or make a new remote param that covers what you're doing at the moment? Like, can we make a scriptlet that essentially does more than what we're currently doing. So I say the Perl method and do it via scriptlets, so we can block more than the current method.
Right. So essentially, the output of Purell is a list of all the query parameters, all the fragments, and all the resource paths that are tracking. And using just the query parameters, I think they can easily be plugged into the existing remove param syntax that uBlock and others use, uBlock and adblock plus use. But there will be some modification which is needed for the resource paths and fragments, because that is directly not supported by the remove param. But the list that Purell generates, the query parameters from those lists, which are around 93% of all the link decorations that we identify, they can be directly used with the remove param function.
Happy with the answer, Ryan?
Yes.
Perfect. Okay, Shaoor, thank you so much for your presentation and for taking time for the questions.